Okay, so in this lovely video, we are going to be talking about the rate of dissolving. Okay, so how do you increase the rate that something will dissolve? Not how do you increase how much will dissolve in a solution, but how do you increase the speed? How do you increase the rate at which it happens? Okay. Okay, so rate of dissolving, okay, has nothing to do with how much solute is going to dissolve. Okay, that has to do with the solubility curve and again, how much, of whatever given solute you can dissolve in a solvent, typically water, okay? This is just talking about the rate. So how fast can I get the solute to dissolve, not how much, okay? So this idea is you want a solute to dissolve faster, okay? You are increasing the rate. You are not changing the amount of solute that's going to be dissolved. Oh, man. Okay, and just remember delta means change. This triangle in science or in chemistry means change. So you're not changing the amount of solute dissolved by shorthand. Okay, so number one thing for a rate of dissolving that you're changing, okay? You cannot change the amount of solvent. So you can't add more water, you can't take out water, okay? You're not changing the concentration at all. That has to do with dilutions if you're changing the amount of water, okay? You also cannot change the amount of solute. If you're adding more solute or you're taking out some solute, that again would change the concentration. So none of those, okay? So there's three ways, okay? Three ways to change your rate of dissolving. Way number one, okay, is really easy. You increase the surface area. We'll talk about all these, okay? Point number two is you stir it. That's the easy one, okay? It's like duh. And point number three is you increase the temp. Okay? All right, so those are three ways. And we're really just going to look at what that means practically, okay? So if I wanted to dissolve salt into water, okay, and I had a cube of salt versus crushed up salt, okay, the crushed up salt is going to dissolve a lot faster. And here's why, okay? The crushed up salt has more surface area, okay? My beautiful pictures, okay? So if I use your imagination, okay? This is a cube of salt, all right? Sodium and chlorine, sodium chloride, all right? If I dropped this into water, okay, it's going to, sink down to the bottom. And then I'm going to have this cube of salt at the bottom of my beaker, whatever, okay, at the bottom of my water. And the water is only able to start dissolving the sodiums and chlorines that are on the outside of the cube. The water's not actually touching a lot of the salt itself, okay? It's only touching the salt that's on the outside. So that's not actually going to dissolve very quickly. If I just let water do its thing, it'll maybe, take off one sodium chloride on this top and then take, one more particle over here. And it's really got to work down to get all of the salt that's in the, middle bottom part of that cube. Versus if I crushed up my cube, okay, I've smashed my cube and, or you just use regular salt, okay, and you have some salt particles that you throw into water. Don't throw them, okay, but you put your salt particles into water. Right away, okay, the surface area is increased, right? Water is able to surround all of these salt particles. So it's much easier for water to separate a sodium chloride particle if it is actually touching the particle. Okay, so I'm going to have these things separate into their respective ions and dissolve much faster. Okay, so if I'm able to, increase the surface area, if I can not have a giant cube of my solute put into my water, and I can have, individual particles or like grains of salt put into my water, it's going to speed up the rate of dissolving. All right, so that's way number one, is you actually increase the surface area. Okay. Way number two is the most basic. It's stirring. Okay. And if I, took some salt and shook it in, okay, and I have some salt and it's in my water now, okay, the water is able to dissolve it pretty easily, but if I stir it up, why did I try to use a spoon? I don't know. Okay, but if I stir everything, okay, it's going to mix everything up much faster, right? The particles are colliding at a faster rate, okay? So not only is the ability for the water to run into a sodium chloride particle, it's increased, right? The probability that those two are going to collide is a higher probability because everything is being swirled around. Not only that, but they're colliding at a higher speed. So they're colliding at a higher rate, meaning, imagine a car crash, right? If you just have a little fender bender, potentially not that much is going to happen. If you're on the freeway and you smash into somebody, well, it's going to be a bigger collision, right? So if I'm moving these things really fast and they collide, it's going to be able to dissociate or dissolve that sodium chloride particle very fast, okay? So if I stir it, everything is moving around, the particles are colliding more, dissolves faster. Okay, and my favorite way that you can dissolve things faster, don't know why, is heat. You add some sweet, sweet heat to it, okay? So I put my water onto a hot plate or over fire, okay, whatever. I make it hotter, okay? I increase the heat, I increase the temperature. If I increase the temperature, all that's doing is increasing the speed of the particles, right? Hopefully, we learned from thermochem, right? Heat is just increasing the kinetic energy of your particles, okay? Temperature is just a measure of the kinetic energy of your particles, so how fast those particles are moving, which we all know, right? If you put your hands together, you rub really fast, you feel the heat, right? So the faster you move, the hotter your hands are. And that is, I think, a really good analogy to understand the way particles and temperature works, okay? So the faster a particle is moving, the hotter its temperature, right? The higher its temperature. The more heat I give it and the hotter the particle gets, the faster it moves. So it's like stirring without having to do any of the legwork, okay? If I'm heating everything up, everything is zipping around really fast. So same principle as stirring, okay? They're going to collide into each other much faster. They are going to be able to dissolve that solute faster, okay? Because they're running into each other more. And that's it, okay? 3 ways to dissolve something faster, really easy, okay? Increase the surface area, stir it, and increase the temperature, okay? Good luck.